You've watched an AI answer. The words don't land all at once. They arrive one at a time. Looks like a loading animation, right? Like the answer already exists somewhere and you're watching it download. It isn't. There is no answer waiting. What you're watching is the machine deciding. It writes one word at a time. And when a word lands, the next one doesn't exist yet. So how does it decide what comes next? This is Owlspect, Chapter 2 of How a Machine Learns to Talk. First, the front door. The machine reads your words as chunks called tokens, and that is all the recap we need. Today, the room behind it, the moment it answers. Watch the typing closely and you'll catch something odd. It speeds up, it slows down, sometimes it hangs mid-sentence for a beat. Some of that is plumbing, network stutter, screens buffer, but under the smoothest stream, something is happening that no download does. Under every single word, a decision. The reasonable guess goes like this. Somewhere inside, there's a warehouse of answers. Your question comes in, the best match goes out. Like a search engine, with better manners. But the warehouse doesn't exist. Nobody ever built one. When an answer arrives, it isn't coming out of storage. It's being made up as it goes. It even explains the pauses, doesn't it? A warehouse search taking its time. Every piece of the guess feels right, and every piece of it is wrong. The machine you're about to see has exactly one move. What actually happens is stranger, and you can watch it. Start with the moment you hit enter. The machine reads everything on the page. Your question? Every word it has already written. Every single time, the whole page, from the top. Then it does its only trick. Every chunk the machine knows, its whole menu, becomes a candidate. Often 100,000 or more. Words, punctuation, pieces of words. Picture them as little blocks. Each one gets scored on a single question. How likely is this to come next? Below the cursor, the candidates rise, a skyline of scores. And scored is the right word. Nothing is looked up anywhere. Every chunk the machine knows simply gets handed a number. It picks one, sticks it on the page. One winner, glued straight onto the page. And then, this is the whole secret, it starts over. It reads the page again, now one word longer, scores every candidate again, and picks again. Watch it once more, slower. Where do the scores come from? Training. It has read more text than any of us ever will, and what it kept, mostly, isn't the pages. It's the patterns. Which words tend to follow which, in what company, at what distance. Billions of tiny statistical habits pressed into the machine during training. For now, take the scores as given. Their origin story is a whole chapter. Nowhere in the machine is there a finished sentence waiting for its turn. No saved draft, not even a hidden notebook to keep one in. Anything it plans fresh from the page. The page is all it keeps. Check for yourself. Hit stop while it's typing. In the machine you've just seen, there is no rest of the answer to recover. It never existed. An essay, a poem, your apology email, same trick every time. There's no essay mode hiding in there, and no switch that flips for poetry. What looks like a genre is just the scores leaning a different way. But wait, if it always took the most likely word, wouldn't the same question get the same answer every time? They don't, because here's the twist. It doesn't always take the favorite. It rolls weighted dice. The favorite usually wins. Usually, not always. The skyline isn't a picture of the dice, it is the dice. Why gamble at all? Because a machine that always picks the favorite tends to walk in circles. It can start repeating itself until you stop it. Early text generators did exactly this, the same phrase again and again. You've already met the dice, by the way, the regenerate button. It doesn't mean think harder. At heart, it means same page, new dice. 3 presses, 3 universes. So tomorrow, the same question gets a different answer, not a mood, just the dice. Watch it happen word by word. 2 runs agree for a stretch, then 1 roll differs, and they fork for good. And the dice explain more than variety. The big one first. The next word only has to be likely. Nothing in the loop checks whether it is true. True things are often also likely. The patterns soak up a lot of the real world. But that's a lucky overlap, not a check. Likelihood is the only currency. It also explains how an answer goes off the rails. Every new word builds on the words already rolled. One bad pick, and every word after it builds on the mistake. You've seen it, an answer that starts confidently wrong and keeps digging. And it explains why your wording matters. The page is the only input. Change one word in your question, and every score changes with it. That's why tiny rephrasings can flip an answer. Ask it for exactly 500 words? Nothing in the loop keeps a tally. It can't count words it hasn't picked yet. Each one doesn't exist until the roll. So it usually lands close, confident, and wrong. And that typewriter effect? Now you know. You're not watching a download. You're watching it decide in real time, word by word. Two questions are still open. Why does the same machine feel boring in one place and unhinged in another? And a dice roll per word. Is it really not thinking ahead? Rhymes need setup. Jokes need timing. That second one, researchers only started to crack open last year. The gamble has a dial. It's called temperature. Turn it down and the dice barely gamble. The favorite almost always wins. Turn it up and the skyline flattens. Underdogs get real chances. The ranking doesn't change. The favorite stays the favorite. The dial changes how much the roll respects the gap. Same page, same scores. 3 settings. Cold. One confident, boring answer nearly every time. Warm. The everyday mix. Hot. Surprises. And nonsense. Nothing about the machine changed, only how bravely it rolls. You felt this dial without ever seeing it. Chat apps don't show you the dial, but the defaults you've met run warmish. And when developers want boring and correct code, contracts, they turn it down. It's part of why one model can feel like 2 different creatures in 2 different apps. 1 asterisk for the curious. Even with the dial at 0, no gamble at all, the same question can still wander. Your question is processed alongside thousands of others. Tiny rounding differences can flip a close call between 2 words. The dice are the randomness someone designed. The serving hardware adds a little of its own. Now the second question. Can a word-at-a-time machine think ahead at all? In 2025, researchers put a microscope inside a model, mid-poem. Before it wrote a line, they found candidates for its final word, the rhyme, already active. The line wasn't assembled left to right and rescued at the end. The destination came first, and it steered every word in between. A target it hadn't written yet. That's a plan. So it does plan. But the strange part is what happens next. The plan is never stored. Nothing is written down beside the page. Next word. The plan is rebuilt from the page, and from nothing else. A planner with no notebook, only the page. Researchers call this field interpretability. We'll spend a whole chapter inside it at the end of the season. So, 1 loop, a dice roll per word, a dial that sets the gamble, and a plan that lives nowhere but the page. That's the writing, all of it. Every behavior you'll meet this season sits on top of this loop. It's the engine room. Before you go, try this. Ask the same question in 2 fresh chats, and watch the fork happen, usually within a sentence. Then find the regenerate button. Same page, new dice. This time you'll know what you're rolling. But we skated past the biggest word in all of this, the scores. Every candidate scored. By what? Nobody typed in 100,000 numbers. Nobody wrote a rule for rhymes or apologies or grammar. So where did it all come from? Next chapter, where the scores came from. The error that teaches. The riverbed it carves. Room 2 of the machine, lit. The loop is yours now. This was Owlspect, Chapter 2 of How a Machine Learns to Talk. We make the invisible parts of AI visible.